Thank you for stopping by. My name is Tom. In this video, I will show you how to find a unit vector. So, how do we go about finding a unit vector? These are the steps that we take. Imagine you're given the following. 2 points, okay? So the first step is imagine you have an x-axis and a y-axis, so a coordinate system. Okay, this is our x, and this is our y. And let's say you're given one point here with coordinates 2 and 3. Okay, so 2 and 3. And then say you're given some other point over here. And the coordinates of this point are, and let's count them now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7. Okay? This is our coordinate system, x-axis, y-axis. The first point is coordinates 2, 3. And the second point is coordinates 10, 7. As follows. So what we can do is draw an arrow between them. And this is what we call a vector. And what we are going to do now is the following. We will find a unit vector in the direction of this one. So let's take a look. What we have, fundamental principle is this. Take a look. Say you have the number 5. If you take 5 and you divide by 5, which you can think of as the length of 5, you get 1. If you have 10 and you divide by 10, you get again 1. So we will apply the same principle in this context as follows. We have u and the unit vector in the direction of this one. Let's call this one here v. Okay, so we will call this vector v. It will be given by v divided by its magnitude or its length. Okay, so v divided by its length or its magnitude will give us a unit vector in that direction. And the unit vector roughly will look like this. Okay, so it lies along the same vector, but its length is 1. Okay, so let's first take what we have and express it in component form. So the vector v is given by the following. To find the x component of the vector, you take the difference of the 10 and the 2. That gives the following. And then to find the y component of vector v, you take the difference of the y's between the 2 points. So that's 7 minus 3. Which means now we have the following. 8 and 4. So these are the components of our vector, and they represent the following. Let's see whether I can throw some color into this process. Well, orange, let's see, purple, blue. Okay, with the one I am drawing right now, this is the x component of the vector. Let's draw here in another color in green or orange, it doesn't matter. That is the y component of the vector. So our vector v consists of 2 components, a vertical one and a horizontal one. That 8 over here represents the horizontal, and the 4 represents the vertical component of the vector. Okay? So the next step, what we're going to do is this. We will take our vector, we will find its length or its magnitude. So the symbols we use to represent this are double vertical bars on each side of v, with the arrow above it. And of course, as you can see in the picture, this is a triangle, so we apply the Pythagorean theorem. So you have 8 squared plus 4 squared, square rooted, which now gives 64 plus 16. this is the same as this number here. So let's simplify this. Here's the number 80. So you can begin anywhere you like, but you might, for example, write 8 times 10 square root, and then observe that this operation can be distributed to each number individually. So now we have the root of 8 times the root of 10. So we simplify this now as follows. 4 times 2 which means what we have is 2 times the root of 20. Okay? If some of these operations seem unfamiliar, you may have to review them, but the big idea with these is this operation of taking square roots. The square root of a product is the product of the square roots, and it goes both this way and that way. So if you're given this, you can go to this, or if you're given this, you can go to that form. Okay? So there's obviously, the more direct way of doing this by writing 20 times 4, but I wanted to show you some of the intermediate details, okay, just to review some relevant rules. So what we can say now is that the length of the arrow from here to here is given by 2 times the root of 20. That's the magnitude of our vector. So now we find the unit as follows. We take the vector 8, 4. We use the letter U to represent the unit vector. Remember, it's V divided by its magnitude. So it's 8, 4. And we divide by 2 root 20. Now let's simplify this a little as 8 over 2 root 20 and 4 over 2 root 20. The 8 divided by the 2 is 4, so we have 4 over root 20. And then we have 4 divided by 2, which is 2, so 2 over root 20, like this. So this is our unit vector in the direction of the original vector as shown in the picture. The original is from this point all the way to this point. The unit is from here to here. Its length is 1. Okay? And the unit vectors have many applications, but just being able to find it first and then draw it along the original vector is a skill. And the relevant ideas, of course, are knowing how to express a vector in component form. That's this step. Knowing how to work with radicals, so you can find the length of a vector. Understanding that to make a quantity of length 1, you take that quantity and you divide it by its length. That's another skill. So thank you for watching.